VDC Beyond 3D, BIM to VDC and developing the use cases for construction. So a little bit about myself. Patrick Lalonde, Senior Director of Digital Project Delivery at Lalonde, one of the largest general contractors in Canada. I've been in the construction industry for about 20 years, working both as a laborer in the office and kind of at a corporate level, as I do now. Been with Lalonde for about 13 plus years. I served as an instructor at Algonquin College Center for Construction Excellence in their BIM Lifecycle Management Program for about 4 years, 2018 to 2022. I sit as a committee member on the CSA group, the Canadian Standards Association, for the digitization of information for the built environment, otherwise known as ISO 19650, and the implementation and adoption of that within Canada. Also sit on the construction management think tank of Building Transformations, a national industry organization in North America, and a board member of Building Smart Canada, as well as a board member and founding member of Digital Built National Capital Region, a local advocacy group for digitization in the built environment. So I want to get started by talking a bit about the history of BIM and VDC, where things came from and how we kind of got to our current state of the use of the technology. So drafting and illustrating, engineering documents, blueprints, and communicating design intent came from sort of the traditional methods of pencil and paper drafting, taking sort of a three-dimensional concept, converting that to 2 dimensions on paper, and those were the blueprints that were sent to the site to execute and build. So, throughout the 50s, 60s, before computers, that was the main way to do that. Then sort of in the early 90s came AutoCAD, or computer-assisted drafting, which essentially digitized or computerized that process of traditional manual drafting, pencil and paper. And so that was a bit of an evolution of that process and a digitization, a first step towards digitization. But what really came as a more of a revolution to the process was the introduction of building information modeling. And so I've got that in there as about 2005. We'll say that, where it became mainstream, but I guess that's still up to the debate of when building information modeling got introduced. But I think mostly mainstream, around the mid 2000s there. And building information modeling can be defined as that process of creating that intelligent 3D based model, that gives AEC professionals the insights and tools to effectively plan, design, and construct and manage buildings. And it's really the definition of that process, building that information model. And so traditionally, model development was only done for a single purpose. It was to produce those blueprints. So going back to the early days of drafting and two-dimensional CAD, we still had that same mindset of developing that model, but only to produce those 2D drawings is the traditional way we've always done it. And so there was a huge amount of untapped potential because we had this very intelligent 3D model and we were reducing it down to 2D PDFs and blueprints. And so over time, we started to realize the potential in these 3D models to do more than just produce the construction documents. They were also supporting our logistics planning. They were supporting the scheduling and sequencing of work. We were able to use them for quantities and material estimates, utilize those models for fabrication and prefabrication through digitized processes and CNC machines and things like that. And then for advanced coordination, So bringing all those models together and actually looking and understanding of what we intend to build and how we design it. And then the visualization piece of really seeing the designs and the design intent in that 3D medium help to visualize and understand and communicate throughout the process. And so that's kind of how we got in from that transition from building information modeling to virtual design and construction. So VDC is sort of an acronym that we use to encompass all of the ways that we use those BIM models throughout the construction process and throughout the building life cycle. And that's where we come down to the VDC use cases. So we've kind of broken down how we use the BIM models throughout the construction process for very specific functions and outcomes throughout the project. And so those use cases are defined into sort of buckets or categories, one being 3D coordination, 3D modeling, 3D logistics, 4D schedule and progress tracking, quantity takeoffs, augmented reality, virtual reality, and extended reality, BIM asset management, reality capture with drones, reality capture with LiDAR, reality capture with 360 photos, and the BIM management piece. And I'll go into details a little bit about explaining these use cases. So with 3D coordination, that's really the bread and butter of what VDC does is centralizing all of that information, all of that 3D information into a single source of truth, and then using that to visualize and understand how multidisciplinary systems interact with each other and work together, sort of virtually building the building first. And working out all those issues. And so I like to make the association of what 3D coordination is. It's not a revolutionary concept. It's not a new concept that we've introduced, into the industry. It's just an evolution of what we've already been doing. Just we're doing it with different tools. So I use the Lightbox, version 1.0 as an example of the exact same process with two-dimensional paper, laying multidisciplinary drawings on top of each other on top of a light box, and you can see it makes the drawings transparent, so you can actually coordinate and see the different systems and if there is any conflicts. And so it's exactly what we're doing, in the BIM world and the VDC world with the models and projectors, is that sort of Lightbox 2.0. Exactly the same process, same people around the table doing the same thing, but with more advanced technology. The next use case is the 3D modeling. We're actually creating very detailed 3D models of exactly what we're planning to install in reality. So in this example, we've got very detailed rebar and sleeving of a bridge pier, so that we can accurately understand and work out any issues associated with all of those components and detail it very specifically in that virtual environment, so we can execute very efficiently in the real world. 3D logistics is taking those logistics plans, which were traditionally done in PDFs. We can insert the BIM models into logistics planning software, create three-dimensional models of all of the road shutdowns, hoarding, excavation, ramps, tower cranes, and start to understand all of those other pieces that make up the construction site. The 4D scheduling and progress tracking, that is taking that 3D model and connecting it to a schedule and being able to animate and watch the sequence of work. So what that entails is taking a traditional schedule, Gantt chart schedule with activities and line items, start and finish dates, and connecting those line items to the geometry in that 3D model. And so you have that time plus 3D equals your 4D. And so what that requires is inputs of your schedule, your 3D model, and then you need to process that information, connecting those elements in specialized software, and then you can have the output of actually having that animation or that video to watch to illustrate that construction sequencing. And then you also have BIM progress tracking, which is an extension related to the 4D, but a bit of a different process. The 4D animations typically project the baseline construction sequence that you're planning to do, and then progress tracking is actually ingesting more actuals back into the system and planning exactly how the different components are starting and finishing. So we can take in the Revit models, the schedules, and plug that into Power BI software, and and itemize exactly the different pieces and the start and finish dates and volumes and quantities associated with those. So we can actually track more detailed progress throughout construction with methods like this. So the 4D animations is one thing, and then the progress tracking is another thing, but they're very interrelated. Next, we have quantity takeoff. So thinking of the models as an itemized inventory of all the building systems and components. We can catalog that, itemize, sort and filter all of those components, and get easy quantity extractions and lists of all of those building systems to support design development and to support procurement process. Next is we have sort of the extended reality, which is both augmented and virtual reality. And what augmented reality is essentially is overlaying the virtual environment, the 3D model, with the real environment. So using devices such as an iPad, iPhone, or sometimes the headset, you can overlay the 3D model with the real space, so you can walk out on site and see exactly what is planned to be installed and see how it interacts with the physical environment. And then there's virtual reality, which is similar technology but slightly different because it's more of an immersive experience. There isn't sort of the combination of the virtual and the physical. It's completely immersed in the virtual world, so you can really get a sense of the environment and the space that may not exist yet. And then you have the BIM management side of things, which is a hugely important part of the VDC process, because setting up the VDC process is just like managing any project. You need to plan accordingly, you need to scope the activities, and then you need to manage and monitor that those activities are being done and the deliverables are being met within a certain time frame. So key components to the BIM management is, the standards and contracts, making sure that you define the specifications, the formats, and any other technical requirements for the project, setting up the workflows, making sure that all stakeholders understand their roles and responsibilities and know the process, setting up the collaboration procedures, managing the communication and coordination between the stakeholders, defining the quality control, the accuracy and completeness of the BIM data, and making sure that it's done accordingly and complies with the requirements. And then there's the training and support, making sure that everyone knows how to use the models and are using them effectively and understands how to access the information that they need. Next is BIM for asset management. So thinking of the model as that digital inventory of all the building assets that can be used for quantity takeoff, but you can also use that as your library or your catalog of all the building systems, all the pumps, all the mechanical equipment, and right down to any level you want, such as furniture or things like that. So what BIM asset management is essentially is that sort of foundation of the digital twin that that's been talked quite a lot about in the industry right now, and that starts from that asset information model. So your asset information is your storage and maintenance, your sort of your static model of all those, your catalog and library of building systems. Then you can connect that with real-time data through IoT devices and make it dynamic, depending on the actual and live readings from those sensors connected to those static information models. And then with that sort of real-time information, you can start to layer in the data analytics, the machine learning and data science, predictive simulations and artificial intelligence, and then ultimately get to decision automation and future predictions of how things are going to go within the building. But you really need to start with that the foundation of that asset information model. And then the reality capture piece, that's kind of broken down into three categories, depending on the capture method. So there's 360 photos, using those 360 photos for interior, LiDAR, which is a LiDAR laser-based system, and then with drones for aerial photography. So reality capture 360 photo, more for interior aspects of the work, tracking the walls, the mechanical systems, the installation, that sort of thing. Reality capture with LiDAR supports the scan to BIM process, validating completed work, doing analysis on concrete and geometry, more for that detailed and high accuracy type use cases. And then there's the reality capture with UAV drones, which is more of that bigger scale, exterior, looking at the site, the foundation work, excavation, steel erection, all that exterior outside site work. That can be captured with the UAV drones. And to summarize, all these use cases, all this virtual design and construction, it's really been fueling a paradigm shift in the construction industry, offering a more intelligent, efficient, and sustainable approach to project management. And as technology continues to advance, the adoption of digital construction practices is expected to become more widespread, shaping the future of our industry. VDC is not only about 3D models, it's about creating cohesive, data-rich environment that empowers efficient decision-making and collaboration throughout the project lifecycle. As the construction industry embraces innovation, VDC will continue to evolve and play a pivotal role in shaping the future. Thank you.